In this video, we're going to take a look at the derivatives of inverse trigonometric functions. Now recall that the inverse sine function satisfies that if I take the inverse sine of sine x, it will equal x for all values of x. However, if I take the sine of the inverse sine, then I only get x when x is between -1 and +1. Now remember, the reason for this is because I want the inverse sine to be a function, then I need to restrict the domain. So now we're going to take a look at how to find the derivative of the inverse sine x. And to do this, we need to use implicit differentiation. So let's rewrite the equation or the function that we want to find the derivative of. I'm going to move the inverse sine back to the left side. So this will be sine y equals x. And now we're going to take the derivative of both sides. And to do this, because we have y on the left with sine, we have to take this to be cos y and then dy dx, because we need to use implicit differentiation. And this equals 1. Isolate my dy dx, and I get 1 over cos y. All right, now I'm not kind of satisfied that I have this y in here. So what I want to do is use sine y equals x to draw a right triangle. So sine y equals x means that this angle is y, my opposite is x, and my hypotenuse is 1. So the adjacent side next to the y is then going to be 1 minus root x squared. So therefore, cos y is going to be root 1 minus x squared over 1. So the derivative of the inverse sine x is actually 1 divided by root 1 minus x squared. Now, we can actually find the other inverse trig functions the same way, but I'm not going to show you this because of time. So here's all of the inverse trig functions for sine, cos, tan, cosecant, secant, and cotangent. So what I'm going to show you here is how to use these formulas. Now they need to be memorized, and now the ones that are used most often is usually sine, cos, tan, and sometimes secant, or I should say the inverse of each one. All right, so if I'm asking you to find the derivative of the inverse sine of a quarter x, we would say that y prime, and according to this, we would be using this formula here, kind of. So we have 1 over the square root of 1 minus our angle. And in this case, not our angle, I should say our ratio. Our ratio is x, and so our ratio here is a quarter. So I'm going to rewrite this as x over 4, and then in brackets, we're going to square that. Now we actually have to apply the chain rule because this formula here is just the it's just the derivative of the inverse. So we now need to find the derivative of the inside, which is a quarter x. So we need to multiply this by a quarter. So we're doing this because of the chain rule. Okay, so now to simplify, we get 1 over square root of 1 minus x squared over 16. And this 4, I'm going to put it in the front here. So now y prime is 1 over 4. And let's simplify this more. So 16 minus x squared over 16. And I can square root 16 in the denominator, and that becomes 4. So let me show you that step there. So the 4's will cancel off. So I have y prime is equal to 1 divided by the root 16 minus x squared. All right, let's do another one. So here we have the inverse tan of 1 over x. So we have y prime is equal to, so this time we're going to use this formula here. So this will be 1 divided by 1 plus 1 over x all squared. And again, we need to apply the chain rule. So times, so we need to find the derivative of this 1 over x. And that would be negative 1 over x squared. So this is the chain rule. Write this down so you know where that came from. And actually, if I take this x squared and I distribute it into my denominator, I will actually just get negative 1 in the numerator, or negative 1 overall. X squared times 1, which is x squared, and then x squared times this 1 over x squared will be 1. So what I've done is I've distributed the x squared. All right, so here's a couple of examples of finding the derivatives of some inverse trig functions.